Good afternoon, I'm Chuck Taylor. I'm the head of the Water Resources section. And when I was putting this talk together, I thought that the actual working title should be how to put 10 pounds of flour in a 1 pound sack. So I've got a lot of stuff crammed in here, and hopefully I won't make too much of a mess to have to clean up afterwards. We'll see how it goes. In water, we're kind of excited about this new strategic plan of transformative integration because we're actually pretty well positioned to take advantage of that. We've actually been doing integrative research for a long time just by the nature of our field. So there's the text that came out of the new strategic plan, which you all can see there. Some of the reasons that water has already been doing integrative research is because our field is really highly diverse, and it's also largely problem oriented. So we actually, a lot of our research addresses the land grant university missions by solving, real world Kentucky problems. And we're very directly interested in research that benefits the citizens and helps protect the environment and so forth. And because it's problem oriented, we typically have to develop teams of researchers that can address different aspects of a problem. So we often work with civil engineers, agricultural specialists, soil scientists. There's just a lot of people that get pulled in on a typical water project, and as time goes on, that becomes more and more critical for us to be able to do. So we're building new partnerships all the time that encompass a very wide spectrum of interest and capabilities in the water field. Another thing is that water is a field-oriented science, and it depends very much on active monitoring. So just from a technological standpoint, we always have to be working to stay up on new technological developments in terms of instrumentation or laboratory analysis. And a lot of times we're borrowing instruments or analytical techniques and things like that from other fields and trying to make them work in water to do unique things. So, like I said, this is very, it's been going on for a long time in water, but it's also a very new and exciting area for us. So as far as the priority issues that face Kentucky and that we deal with in our research, again, it's a very broad spectrum, and hence that was the problem of trying to figure out what to fit into this talk. But you can see there some of the things I've listed that have risen to the top in recent years that are critical water issues. Water availability and sustainability is not thought of as being a big issue in this state because we're pretty rich in surface water. We don't have the dry climate of some of the western states. But when it comes down to, where's water available and is it available, is enough of it available for the specific use that we need to have, that's where it becomes a little more tricky. Groundwater is becoming more and more important in terms of water availability, especially for agriculture and energy sections. So improved groundwater monitoring and understanding more about our aquifers, that's becoming more critical as time goes on. And tied into that is source water management and protection. Agricultural water quality and soil health is a big issue these days. The agricultural sector has been very concerned about the way they're perceived, and also just from an economic standpoint, being able to manage their resources better, not only water, but soil and erosion and things like that. All that ties into hydrology and water. So that's becoming increasingly important in Kentucky because so much of our economy is now moving very heavily towards agricultural-based development. Groundwater quality in areas of unconventional oil and gas development. That's you read the news every day, and there's something related to fracking or groundwater quality where and groundwater concerns where there's oil and gas development. And traditionally, our program has long been involved and very active in karst hydrogeology and sinkholes and things like that. And that's another thing that seems to hit the news quite often. You see reports of sinkholes that have occurred that have swallowed houses, buildings, people in some cases, so forth. So these are all fields that we're very active in and we expect to be continually active in. And for the rest of my time, I'd like to just sort of highlight a few little aspects here from that list. To show you some things that we're doing that we think also sort of ties into this integrative or transformational research. And we also are excited about the potential collaborations and partnerships that we're developing. First of all, groundwater monitoring. I think a lot of people will be surprised to know that Kentucky has, for several decades, been lacking a statewide groundwater observation network that allows us to really critically track the conditions of our aquifers, how much is being recharged, how much is being depleted, how much is available in storage. And the list on the left are a bunch of state and federal agencies and organizations or entities that have come together that have been specifically interested in trying to tackle the issue of how can we learn more about our groundwater conditions. And because of that, in part, KGS took the initiative to try to begin rebuilding a statewide groundwater observation network just a couple of years ago. If you look on this little map at the bottom here, this was pulled off in March of 2015. You'll notice that this shows active groundwater level monitoring sites across the United States, and Kentucky just appeared as a big white hole for the most part in that map. There's actually one well that was being monitored as part of, that didn't work. Okay, that's all right. There we go. One well was being monitored in far western Kentucky in the Jackson Purchase area by the USGS. And so the rest of our state, we really didn't have any idea what the current groundwater conditions are or a way to be able to assess if groundwater is being depleted, do we have excess groundwater available and so forth. So in just 2 years through KGS efforts, we've begun reestablishing a statewide network. And we now have 11 wells that are presently instrumented with continuous monitoring equipment. As you can see, the distribution, those are the green dots across the state. And we also have, I should say also, we have a goal of reaching a 15 to 20 well network by the end of this year. And we've also picked up two karst springs in the state as long-term observation stations to try to help assess the status of groundwater. This is nowhere near enough wells to do that job, but you've got to start somewhere. We're building slowly. We're trying to target areas of critical need or special interest first and make sure that we've got resources devoted to collecting data in those areas. I mentioned that the USGS had one observation well in the far western part of the state. And again, because groundwater monitoring nationally is becoming a bigger and bigger issue, they were able to get some funding from the national program to add a couple more sites. And so they've added 3 more observation wells. And those are the black dots you can see on here just this last year. So we went, in 2 years, we've gone from basically nothing to a pretty nice little skeletal network. And I think that's a pretty good accomplishment, actually. And we hope to continue building on that, collecting more data and making this a systematic program effort so that, it just doesn't fall through the cracks anymore. In building this network, we've managed to also build some new partnerships that we're excited about. And the data that we collect not only is good for assessing water availability, but they'll also help us to sort of delve into some very particular research type issues. One of the partnerships we developed is with Murray State University at their Hudson School of Agriculture. We specifically sought out their site because we were interested in monitoring 2 aquifers in the Jackson Purchase area that are extensively used for agriculture as well as for municipal water supplies. And so we were able to work with them to put in an observation well cluster at their ag farm that targets these 2 critical aquifer zones. And as a result, they're also interested in having us come down and talk to their students and work more interactively with their researchers on issues related to using groundwater for agriculture. Another new partnership that we developed is with Mammoth Cave National Park, where we're again putting in a cluster of observation wells, one that actually targets a cave stream passage, but the other is in fractured limestone rock. And that's going to be in the Turnhole Spring Basin. And, karst is a significant issue in this state since 55 to 60% of the state's area is karstic. And so it's not a trivial matter to understand better, how groundwater works in karst. And we're hoping that this observation well cluster and working with the National Park Service scientists can help us develop some research related to that area. And then just recently, last fall, as a matter of fact, we partnered with Hardin County Water District Number 1 through a Division of Water Source Water Protection grant to establish a long-term spring discharge and water quality monitoring station at head of Rough Spring. That was one of the points on the map I showed. And so we're excited about that. Karst springs have not been monitored very much in terms of collecting long-term flow data. in this state. So this is one of the first, it's not the first, but it's one of the first long-term observation stations for karst springs. So I think that could be a great benefit to understanding karst aquifers as well. Some of you may know also that the legislature established a new board for dealing with water resources issues just a year or two ago. And they started to take shape and meet and to try to decide what their priorities are. Water availability is, again, the big issue, making sure that water is available for all the economic interests of the state and the various competing interests of the state. And so one of the obvious questions was, you can't really regulate, or rather, I shouldn't say regulate, but manage a resource if you really don't understand it. So one of the first things they came to us who deal with water research is, well, how much water is available in the state? Do we know how much is in surface water? Do we know how much groundwater we have? Where is it? And that sounds like a pretty simple question, but it's actually pretty technically challenging to determine. And in some cases, we just don't really have the data to be able to answer that question. So a group of us are getting together as a data working group for the board. The DOW is involved in this, USGS, the UK Water Resources Institute, and the Kentucky Climate Center from Western Kentucky University. We're all talking about how are we going to do this, actually develop a water budget for all of the stream basins in the state. It sounds simple. Again, it's an accounting issue. Basically, you just measure all the inputs coming into streams and the things that are going out of the streams. But again, when it comes to things like ET or groundwater recharge, base flow springs, it's a little difficult, sometimes technically challenging to get good estimates, reliable estimates on those things. And of course, we don't have stream discharge measured everywhere in the state that we need it. So there are going to be some modeling methods or other things that need to be considered to be able to estimate those things reliably. And even when it comes to knowing how much is actually being pulled out, both in terms of groundwater and surface water, we don't always have data on that. The agricultural producers are not required when they use a groundwater well to report how much groundwater they're withdrawing to the state. So we have no idea, really. We can estimate it very roughly. We have no idea in a lot of cases what those actual numbers of withdrawals are. So again, dealing with this issue, how we can practically solve it is going to be an interesting research project. And if we're able to do it, it's going to be, to me, the ultimate integration of hydrological, meteorological, and water use data. Again, going back to the agricultural water quality and soil health issue, we're excited about this. This is a recent partnership we just established with the UK College of Agriculture, Agricultural Extension. Glenn Beck on our staff has been working really closely with Brad Lee at Ag Extension to put this project together. Sorry about that, I seem to change something here. And we're also working with the USDA NRCS, and this particular project is being funded in part by the Kentucky Soybean Board. So there's public and private concerns here putting together this project. It's called the Blue Water Farms Edge of Field Surface Water Monitoring Project. And the idea is to select a bunch of different farm sites that have different cropping methods, different management methods, and start monitoring in a high level of detail the water and loads of agriculture-related constituents that are coming off of those fields into Kentucky streams. And so the idea behind that is that we're going to be able to collect some data that will help demonstrate or help improve this type of conservation practices that are typically employed at Kentucky farms. And so this project's going to begin in the fall. It's a multi-year project. We anticipate it being 10 years in duration ultimately. And you can see here an example of a typical type of installation that's set up to monitor the surface runoff coming off of produced fields. It's not a simple thing. And so to do that at multiple sites is going to be quite a technically challenging effort. Another project we have going on that is similar is this one here. And it's a collaboration between us and the NRCS and a private 5013C entity called Home Place on Green River. It's a historical farm place that's actually being used now to promote agricultural awareness and education. And so it was selected to be an edge of field monitoring site before anybody realized that it's a karst area. And so the question is, okay, what do you monitor when it comes to karst? You have the rainfall and the soil runoff going into these sinkholes and being drained underground. So how do you set up an effective and meaningful monitoring program in a karst area? So this is one of the questions that we're trying to answer here. This project is involving, to start off with, you have to understand that karst system that drains that farm area. So we're starting off with the basics of trying to characterize the sinkhole drainage characteristics at the farm, underground karst flow paths, and then the runoff, rainfall runoff responses of both into the sinkholes and coming from the spring that's receiving the water that's drained by those sinkholes. And to do that, we're sort of throwing at everything, you know, the kitchen sink and everything else approach at this, because there's a lot of different types of information we need to collect. But so it's giving us an opportunity to try some unique methods. And just to highlight this here, you know, this is another example of where LiDAR is being very effective and helpful. This is a LiDAR derived map of sinkhole locations and actually their catchment areas. You can actually see the size and depth of the sinkholes that are draining the topography here at the farm, which is this larger red polygon here. And so this is a top or high-low sort of approach here. We're using the LiDAR to get the high, you know, bird's eye view of the farm. And we're also going back out and running electrical resistivity surveys to see what's down below the land surface. And so we've run some ER surveys at different locations across the farm site to see if we can actually spot or identify karst conduits that are draining these farm fields, and just to help characterize, again, the overall permeability of the limestone, get an idea of the soil thickness and so forth. That will help us understand this problem of you know, agricultural water quality at karst areas. And this is really, in a way, that topic is nothing new. KGS years ago did several large studies. The study that was done by Jim Kearns at Pleasant Grove Spring addressed this topic. But again, there's a bigger focus these days on active monitoring and what sort of data you need to collect to understand the system that you're trying to monitor, and how you can use that information to make practical management-based decisions that aids Kentucky agriculture. And then finally, we also last year initiated a very large groundwater quality study in the Berea, Rogersville Play area. We sampled 51 wells there, and among other things, it was a very interesting study, but among other things, we detected a lot of methane in the groundwater in these wells. And it isn't unexpected, but it was kind of eye-opening. Methane is probably a broader constituent of groundwater that I think has been recognized. And of course, the issue there is that a lot of people look at the occurrence of methane as an indicator that the groundwater has been affected by fracking, oil and gas development. But the problem with that is that there's methane and there's methane. Some of it is biologically sourced. And the isotopic analysis that we performed on the groundwater sample showed that much, if not most, of the methane that we detected in these wells is from microbial respiration. So we want to do a follow-up study to look at the processes that are generating methane in these shallower water, shallower aquifers, and see if we can understand, especially the microbe communities and how the chemical evolution of the water occurs. And to do that, we partnered, members of our staff in the energy section are partnering up with a microbial group, the Wrighton Microbe Biome Laboratory at Ohio State. We're just now talking about a project, how to scope this thing, but we're probably going to start doing some work this fall to sample, to actually start looking at the microbe communities that are involved in methane generation in shallow aquifers. So that is it for me. I appreciate your attention, and hopefully I didn't just sort of overwhelm you. I guess we have time for a question or two, maybe. Yes, sir.
Back when we went back to where Kentucky started out with one groundwater monitors as well, but didn't the USGS monitor groundwater, especially
yes.
in Louisville and Kentucky earlier?
Yes.
Do they have a record of that?
Yeah, it's a long story, but it basically comes down to funding cuts and priorities for monitoring. And so back in the early, well, I guess the 50s up through about the late 80s, there was a number of wells that were being monitored, but all those went away due to mainly the federal budget cuts and by the early 1990s. And so USGS maintained one site that they used for long-term climate-related monitoring. They did have a small cluster of wells that they maintained in the Louisville area to monitor water levels under the city. But again, as far as a systematic program or observation well sites to collect groundwater level data over the long term, all that went away. And so we're basically having to restart that. Any more questions? All right, thank you.